Unit 14, Part 2. Okay, the big lesson for Unit 14 is learning to distinguish when formulas are in quantifier form from when formulas are not in quantifier form. Why is that so important? Because we're heading into Unit 15, the big climax of the section on quantifier logic, where we do proofs, and you'll be presented with things like this, where your premises and your negations, you have to grasp that these formulas are not in quantifier form because they are negations, and a formula is always either in quantifier form or in truth functional form, right? A formula is either a universal statement or an existential statement or a negation or a conjunction or a conditional, so on and so forth. It's always one or the other. Very crucial you grasp that. So you're confused if you're thinking, well, this is a universal statement, but it's also a conditional because it has a conditional as the measure. Nope. It's one or the other, right? Or the other, one or the other. So don't be confused. There's one definite answer to the question, what is the form of this statement? The answer can be a universal statement or an existential statement, and if that is the answer is not that it's a conditional or a disjunction or whatever. Okay, so why is the lesson of Unit 14 so important? Because you'll be presented with proofs like these, and the first thought you have to have is, oh dear, I cannot use the rules governing quantifiers, instantiation and generalization rules, on any of these formulas in the form in which they appear, because they are not in quantifier form, and because I know, because they stressed it so much, it was the whole point of Unit 14, that I'm talking about quantifier logic, is what I'm talking about. Yeah, I'll get to what it means in a minute. The whole point of Unit 14 was to teach us that formulas have to be in quantifier form to apply the rules. I think that's what I was going to say. Anyway, so you see this, and so you've got to grasp that they're not in quantifier form. They are rather than negations. We need them in quantifier form to be able to use the rules that we're going to need to use the rules on proofs in quantifier logic, right? Because these four new rules, instantiation and generalization rules, are the rules governing the adding on and taking off of quantifiers. So we have to transform them, right? So we desire that these formulas be in equivalent forms which are in quantifier form, so we need to get them into that formula. We recognize that they are not because, why? Big lesson Unit 14. There are two conditions to be in quantifier form. First condition is that it starts with a quantifier. All these formulas start with negations and thus are not in quantifier form. In fact, I should read you page 266, paragraph 3. So far we have said nothing about negations, but these will be extremely important when we come to proofs. So it's 266 from Unit 14. Third paragraph. The first condition for a formula to be in quantifier form is that it begins with a quantifier, and this rules out formulas such as not for all x if fx then gx. No negated quantifier statement is considered a quantifier formula. It is a negation, one of the 5 truth functional compounds. You will be able to use the 4 quantifier rules only on quantifier statements. And this means not on negations. Thus, it is very important to be acutely aware of the difference. Thank you. On negated formulas, you will use Qn or CQn first, and this is exactly what I'm about to do. Again, a formula that begins with a negation cannot begin with a quantifier, so it cannot be a quantifier formula, right? She's just stressing this either-or thing that I am stressing, right? If it's a negation, it's not in quantifier form. So don't make the mistake of seeing this and not paying attention to the fact that it's a negation when you need to do proofs, and thinking you can do a UI, that's the rule, universal instantiation, on something like this. You cannot, right? And this is a mistake that many people make, right? You see this and you somehow try to instantiate from this. You can't. It's not in quantifier form. You're not allowed to instantiate. It's not in the form of the premise of the rule of universal instantiation. That premise is given the premise is a universal statement. Given a universal statement, you're allowed to delete the quantifier, replace that variable with any individual individual constant. We'll see that in Unit 15. I will actually do one in this proof. But okay, so what you have to do, knowing all that stuff, is realize that this is where you have to use the, in this case, CQN rules, right? And because the result of doing a CQN, both on premise 1 and 2, and reverse from the conclusion, negation there, the result will always be a statement in quantifier form. And those ones, right, the ones that result at the top from CQNing the premises, they'll be in quantifier form. We can instantiate from them. And down the bottom, working backwards, we'll have a formula that's in quantifier form. We'll be able to generalize to that, because the generalization rules, the form of generalization rules is from a truth functional statement, you're allowed to infer, conclusion, a quantifier statement.